we go. Hello, algebra. So we've learned about graphing systems of linear equations to solve them. We've learned about substituting, and the third and final way is elimination. All right, that's the third and final way. So we'll talk more in the meets about like how to pick the best way and which way makes sense. You can use any of these ways on any of the lines, but I think there are times where it makes more sense than other times. So elimination, for example, makes a lot of sense when you have the same variable and they already have like the same coefficient. And it would be a pain to have to solve these, right? Like we could solve this one for x, that's not too bad, but then having to substitute in, that's going to take us a while. And graphing these is not the most convenient. It's not going to be a very pretty graph. So elimination is kind of that good, all right, if the other two aren't very easy, elimination might be the way to go. So the first step, we want to write the system so that the like terms are aligned, so that they're on top of each other, all right? So I'm going to rewrite this one, for example. I'm going to write my y's first. Actually, let's do x's first. So x minus 2y equals negative 19, which means I need to write this x first as well. So it would have 5x, and then I have a positive 2y there, and it equals 1. So that's the first step. Write them on top of each other. The second step says to eliminate one of the variables and solve for the other one. So here's what I mean. I want you to literally add them together, okay? Like you're doing, math back in second grade or whatever, when we had, we had to line up the tens and the ones and the hundreds column and then add them. That's all we're going to do. We're just going to add like terms. We're going to combine them and see what we get. So we've got 1x plus 5x is 6x. Negative 2y plus positive 2y is 0y. And then negative 19 plus 1 is negative 18. All right, and that's what we get. Now here's the nice thing. 0 times anything is 0. So we really have 6x plus 0 is equal to negative 18. Well, wait a second. 6x plus 0 is just 6x. Hey, look at that. We're one step away from solving this. So I just need to divide both sides by 6, and we get x is equal to negative 3. So now that we know one of our variables, we're on to step 3 here, which says to substitute the value of the variable into one of the original equations and solve for the other variable. Doesn't matter which one we pick. I'm going to go with this second one here. So 2y plus 5x equals 1. And I want to substitute in my x equals 3. So 2y plus 5 parentheses negative 3 equals 1. So that means I have 2y equals plus negative 15 equals 1. I'm going to rewrite this so that it's just minus 15, because then I know I need to add 15 on both sides. So we get 2y is equal to 16. When we divide by 2, we get y equals 8. We get y equals 8. So now that I know that, step 4 says to write the answers from step 2 and 3 as an ordered pair. So that means my ordered pair would be negative 3, 8. And of course, it didn't say it on here, but step 5 is to check always. So we need to do a check. And we always start with the original equations. So we're going to have x minus 2y equals negative 19. And then 2y plus 5x equals 1. So not these ones, these are the originals, all right? These are the originals. So we're going to plug in negative 3 minus 2 times 8 equals negative 19. Well, 2 times 8 is going to get you 16. Negative 3 minus 16 is negative 19. Does negative 19 equal negative 19? Yes, it does. And then for this one, we'd have 2 times plus 5 times negative 3. 2 times 8 is 16. Negative 5, or negative 3 times 5, excuse me, is negative 15. 16 minus 15 is 1. Does 1 equal 1? Yes, it does. So we have, in fact, checked and proven that this is our final answer, negative 3, 8. The next one that we want to do, I'm going to start up here. There we go. We've got 3x plus 2y equals 4. Then we've got negative 2y plus 3x equals negative 4. Now, you could do either of these, right, because they have the same coefficients. I choose these two, the y's, because one's positive and one's negative, and they have the same coefficients. So that just makes it even easier, okay, in my opinion. So I'm going to align them up so I have my y's on top of each other. When I solve that, I get this, right? 0 plus 0y plus 6x equals 0. So that's really 6y equals 0. And then when I divide both sides by 6, we get x equals 0. So then I'm going to take that and plug that into my 3x plus 2y. So 3 times 0, which is 0, plus 2y is 4. And then divide both sides by 2, so I get a y equals 2. So that means my final answer is this 0, 2, right? That's my final answer. Then when I go to check it, I plug in 0 and 2 in both of them. You get 4 equals 4 for the first one, which is great. You get negative 4 equals negative 4 for the second one, which is great. So it is, in fact, a solution. It is, in fact, a solution. All right. Here is the next one. So this one's a little trickier. And I start with this one up here. Neither of these have the same coefficients, right? Like, they don't have the same coefficients. How do we eliminate that? Wouldn't it be easier to substitute? No. This is actually easiest done with elimination still, and I want to show you. And I'm going to do, let's do the x's, because I haven't done them yet. So we've got 5 and 10. How do I get from 5 to 10? What do I have to multiply by? By 2, right? So that means I'm going to take this guy, and I'm going to times everything by negative 2. So that means my negative 5x times negative 2 turns into a positive 10x. My negative 6y times negative 2 turns into a positive 12y. And then my negative 12 times negative 2 turns into a positive 24. All right. So now that I have converted so that we have a positive 10x and a negative 10x, now I can eliminate just like we were doing before. But that's the key here, is being able to convert one equation and just times everything by the same number so that you have coefficients that are opposites. All right. So down here, for example, I'm just going to skip a little bit. We've got a 5x and a 7y, or 7x, or we've got negative 12y and a negative 8y. You can do it with either one. I prefer the x's because they're primes. So I can take my top one here and times it by 5. And I can take the bottom one here and times it by negative 7, for example. All right. And in that case, we would get things like 35x minus 60y is equal to negative 110. And then negative 7 times 35 is negative 35x. Negative 7 times negative 8 is a positive 56y. And then negative 14 times negative 7 is positive 98. So now that I have those, oh, look, my x's are aligned on top of each other. Now I can eliminate them. So this is 0x minus 4y is equal to negative 110 plus 98 gets you negative 12. And I can solve it for there, right? Just like we've been doing. So let's check out this one. For this one, we would have 10x plus negative 10x, plus 3y is equal to 1. I'm adding them together, remember? So this is 0x plus 15y is equal to 25. So that's really 0 plus 15y is equal to 25. So we have 15y is equal to 25. If I divide both sides by 15, we get, I can reduce that down because both of them are divisible by 5. So this should be 5/3. Yay, a fraction. I know you love them. So now I need to plug that into either of these. Doesn't matter which one. I'm going to go with my top one. So the negative 10x plus 3y equals 1. I'm going to plug in my 5/3. Here's why it's super important to keep the fraction. Do not round it. So negative 10x plus 3 times 5/3. I can actually multiply these because they're fractions, right? Fraction times a fraction, super easy to do. That'd be 3 times 5, which is 15, over 1 times 3, which is 3. So I get 15/3. And then 15/3 is really 5. I can reduce that down. So this is why it's awesome. Because if you had rounded this to like 0.3 or something, or whatever this is, it would have been rounded down here, and it wouldn't have come out so beautiful as just 5. Fractions. Keep them as fractions. So I need to subtract 5 on both sides. We get negative 10x is equal to negative 4. I divide by negative 10, and we get x is equal to 2/5, positive 2/5. So that means my final answer is going to be 2/5, 5/3. And yes, you should check it. I'm not going to, though, for the sake of time. So let's take a look at items. All right, the first one here says a business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Location A has 5 large and 2 small for a total cost. Total, hint, hint. That equals, right? $235,000. So that means we've got 5 large and 2 small. So we need to decide something. I'm going to use L for large vans and V for small vans. All right, that's what I'm going to do. L for large, V for small. Location B, it says 2 large vans, and 3 small vans. So this would be an and right there, right? And you've got 2 and 3 for a total of $160,000. So you should have something like this for your equations, all right? Something like this for your equations. And we're going to have to take one of them and multiply by either 2 and the other one by 3, or 1 by 5 and the other one by 2. It doesn't really matter. It really doesn't. So I'm going to pick to convert this one by timesing it. Let's try to eliminate the L's. So one of them has a 5, the other one has a 2, so that means I want to multiply this guy by 5. I'm going to multiply this guy by 2 and see what happens. So this one should be 470,000. 10L plus 4V, and this one I'll do it by a negative 5. So negative 800,000 equals negative 10L minus 15V. All right, 800. There's a 0 missing. So then I can move my 470, 10L plus 4V over here. I need to add them together. So we get negative 330,000. I think that was one too many zeros this time. Equals 0L, right? Because negative 10 plus 10 is 0, minus 11V. So this is really negative 330,000 equals 0 minus 11V. So that's negative 330,000 equals negative 11V. I need to divide both sides by negative 11. So then we get 30,000. There. So the small vans cost 30,000. Well, how much does the large van cost? Let's just use this guy right here. So 470,000 is equal to 10 large plus 4. I'm going to take out my V and put in my 30,000. There we go. Well, that would be 10 large vans plus 120,000 is what the company paid for the small vans. So I have to subtract 120,000 from each side. So we get 350,000 equals 10 large. So when I divide by 10, we get 35,000 for the large. Ooh, one too many zeros. There we go. Ooh, I think I was supposed to plug it into this equation too. Ooh, definitely need to do a check. So my large van should cost 35,000. My small van should cost 30,000. The other word problem. You and your friend are buying throw blankets with your names embroidered on them. The cost of the throw blankets is X, and the cost of the embroidered letters is $Y. All right, your name has 6 letters, and the total cost is 29. Now that includes the blanket and the embroidered letters. All right, so at a minimum, you're going to have an end Y, but how many letters did you have? You had 6. And it was a total cost, so then it equaled 29. So try doing this one on your own. Your friend's name has 3 letters and the total cost is $24.50. Ask yourself this first. Are the blankets going to be the same? Yeah. So they both need to have an X, but your friend has 3 letters and a total cost of $24.50. So take a second, try it out. All right, hopefully you got this for your second equation, right? So now you just need to solve them by elimination. Since these both have plus x's, I would just turn one of them into minuses. That way it was easier. Yeah. Email me if you have any questions on this. I'm happy to help you. And I think I pulled this one up, actually. I did. So here is the answer to that guy. Your blanket, your friend's blanket. We turn one of them into a minus, right? So we subtract everything. You get 3y equals 450. Divide by 3. So it's $1.50 per letter. And then when we plug $1.50 back in, that means the blanket itself costs $20. Costs $20. I do this with Shutterfly sometimes because I like to buy books and stuff for my kids. So if you have any questions, feel free to email me. I am happy to help. All right, you can do this.